All right, and let's go on to section 10.10, volume of rectangular prisms. Now, the big key difference that we're going to be looking at in this section is this word, volume. And it's going to be different than what we've been talking about previously, which was surface area. So let me draw a quick rectangular prism, and I'm going to choose a favorite. I'm going to choose a cube real quick. And let's look at the difference between volume and surface area. All right, if I have my cube here, kind of. And if I was looking for its surface area, recall that I'm kind of looking at the edges here. And it's kind of like if I wanted to paint the edges, paint the sides, or if I wanted to like put wallpaper on. And this is surface area. Now, if I'm looking at volume, it's different, right? Volume, let me draw my cube again. See if I can do better this time. Well, not really cube-like. It's more of a rectangular prism this time, but that's okay. And this time, I am kind of filling it up. It's almost like I have like a bucket. And the bucket is kind of pouring out, and I have the space inside is kind of filled up here. And I'm kind of filling it up as it goes, and I want to know how much space is inside. Or how much space does the shape take up? Now, this would be very useful if I'm trying to fill something with water or if I'm trying to pack something in a box and I want to know how much it holds. So instead of the edges all on the outside, we're talking about filling it up, and that's what makes volume in this case. Now, what's nice is for our rectangular prisms, our volume is actually pretty easy to calculate. So let's take a look at two different boxes quick. We have box A and box B. And box A has height of 5 inches, length of 18 inches, and width of 10 inches. Box B has height of 8, length of 10, and width of 12. And my question is, which of these takes up the most space? Or what can I fit the most inside of if these are boxes? And what I could do is, I could build them in space and measure it out and kind of see what's inside or try putting stuff inside. But that would take a long time. Instead, I'm just going to be calculating my volume. Now, my volume is pretty easy to calculate. Let's look again at our box. Let's use box A in this case. Looks like our length is 18. Our width, we'll call this 10, and our height is 5. So let's say we kind of have this box. In order to find volume, all I'm really doing with these shapes is I'm finding the base, which is down here at the bottom, and I'm multiplying it by my height. I'm kind of pulling it up, almost like in Tinkercad, when you can kind of grab that one little arrow and make this shape bigger or smaller. That's what I'm doing in this case with my volume. So my volume for a rectangular prism is really just going to be my base, which my base in this case I can break apart into length times width, and then I can multiply it by my height. So my big formula that I'm going to be using, my volume of a rectangular prism, is simply going to be length times width times height. And something interesting will also happen with the units, and let's take a look. Let's return back to our boxes. And I kind of covered up a bunch of space, so I'm going to have to do it over here. Let's look at box A. Its volume is going to be equal to length times width times height. Now, it doesn't actually matter what order I multiply these in because of my commutative property. And it doesn't really matter which I call which as long as I remember that I'm multiplying all of them. So let's take a look. We have 18 inches times width, which is 10 inches, times height, which is 5 inches. Now, I did it in the right order, though you don't actually have to. And I'm going to multiply all those together. I'm going to load up my calculator because it's a little much for me to do in my head all at once. And I'm going to do 18 times 10 times 5 is 900. But that's not everything that I'm multiplying. I'm also multiplying inches times inches times inches. Recall that inches times inches is square inches, but in this case I have 3 inches times each other, so I have inches cubed. And that kind of makes sense because cubed is my measurement of volume, because a square is flat and a cube takes up space. So whenever I have units of volume, I will always have cubed. That will always be in there. And if it isn't, then it doesn't make sense and I've done something wrong. This is my box A. Let's take a look at box B. And it's going to be volume equals length times width times height. I have length of 10 inches, width of 12 inches, and height of 8 inches. I forgot to put inches over here. Sorry. 10 times 12 times 8. Let me load up my calculator. 10 times 12 times 8 is 960. Inches times inches times inches is inches cubed. Clearly, box B is larger. And that's definitive because I can multiply the volume out. This is kind of how I do these things. You're going to be finding the area of boxes. I'll do one more if you want to see, but if you kind of get it, then go ahead and go on. Let's do one more example down at the bottom. Let me find another box that I like. We have this box, and let's say that we have, this is 16 centimeters, 9 centimeters, and 4 centimeters. My volume here is going to be equal to length times width times height, or really just multiplying all 3 dimensions. So I'm going to do 4 centimeters times 9 centimeters. This was supposed to be a 9, times 16 centimeters. 4 times 9 times 16 is 576 centimeters cubed. All right, go ahead and good luck.